So let's take a look at question 11. First of all, it says that the small equilateral triangle each have area 4 centimeters squared. So this is a very common equilateral triangle grid. And what is the area of the shaded region? So there are many ways we can do it. One of the easier ways, or like the lazier ways, is to do it like this. So if you cut it up like that, you can see that, well, the shaded area is going to be half of each shape I have enclosed here. Does it make sense? So it's half of this parallelogram, it's half of this parallelogram, and it's half of this equilateral triangle. So you just need to count how many equilateral triangles are there in, well, this region, this trapezium. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 5, 7, 9, 11, and 13. Which means altogether there will be 9 times 5, which is 45 equilateral triangles, or like small equilateral triangles. And the area is equal to 45 times 4, which is equal to 180 centimeters squared. So the area shaded is half of that, which is 90. All right. So that's going to be 90 centimeters squared. Question number 12. Interesting question. So, number puzzle question. We need to know that any 2 unit digits added up must be, well, less than 20. Yeah. And if I have a 2-digit number or a 1-digit number adding another 2-digit number, and I get a 3-digit number, of course it can't be greater than 200, right? It has to be smaller than 200, of course. So it means that this is going to be a 1. So 111. Now I have 2 numbers adding together, so that's going to be even. If I have an even number adding an odd number, that's going to be odd, right? So it means that the 2 circles is going to be an odd 2-digit number. And most likely it's going to be 99 because, well, if it is 88, then of course adding 2 even numbers, you can still reach a 3-digit value. But if it is 77, then, well, the 2 even numbers added up, because they are 1-digit numbers, it has to be less than 20, so it won't work. So it has to be 99 right there. And then we know that 111 take away 99 is 12, so each of these are 6. So the square represents 6. Okay? Not too hard of a problem. And question number 13. The sum of 10 distinct positive integers is 100. What is the largest possible value of any of these 10 integers? Okay, so basically if I want to find the largest possible value of one of them, it means that the other 9 are the smallest, which are going to be 1, 2, 3, all the way to 9. And that's 45. So the maximum is 100 take away 45. That is going to be 55. Alright, so the answer is A. Alright, so take a look at question 14. It shows 5 circles, same radius, touching each other. A circle is drawn such that the vertices are at the centers of the 4 outer circles. So I want to know the ratio of the area of the shaded parts of the circles to the area of the unshaded parts. Very nice, very nice. So basically, you can see that it's going to be the radius, right? So what can you say about the area of the square? The area of the square is going to be 4r in brackets squared in total. All right. So that's the area of the square divided by 2, of course, which is going to be 8r squared. That's the area of the square. And now what about the area of the circles? So you can see that each circle is having an area of pi r squared, right? And then this is a quarter circle, this is a quarter circle, a quarter circle, a quarter circle. So it means that I have 2 circles in it. I have 2 circles inside this square, which means that the area is going to be 2 pi r squared. So the area of shaded parts to the area of unshaded parts is going to be 2 pi to 8 take away 2 pi. Shaded parts of the circles to the unshaded parts of the circles. I see. So it's not about the square. Sorry. So basically I have 4 quarter circles there and a full circle, which makes 2 circles. And then I have 4 of 3 quarter circles, which makes 3 circles. So it's just 2 to 3. Yeah, sorry about it. I didn't think that it's so easy. And for question number 15, okay. The perimeter of the garden is 24 meters shorter than the distance along the outside edge. So, you can say that if the path has constant width, then the perimeter of the garden contains width and length, right? So this is equal to the width, equal to the width, equal to the length, equal to the length. Length. So it means that these are the width of the path, let's say P. So I have 1, 2, 3, 4, 5, 6, 7, 8 of the P's. So 8 of the P's is equal to 24 meters that are shorter, which means P is 3 meters. So the answer is going to be C for this one, okay? So that's for the questions 11 to 15.